In the terminology of object-oriented programming, a field is a variable that's a member of a class, and a field that's only available from an instance of the class is called an instance field. Visual Basic supports the use of instance fields, and they're valuable when you want to wrap both data and functionality in a custom class. I'll show how to do this in the solution instance fields in a version of my simple calculator. I've opened my Calc utility class that I created in a previous movie. This class currently has shared functions. A shared function is the equivalent in Java of a static method. It's available from the class itself without having to instantiate the class. But if you want to work with instance fields, you have to turn these functions into instance functions. And you do that by removing the keyword shared. So I'm going to start this exercise by removing the keyword shared from all of these functions. I'll do it for the add, subtract, multiply, and divide functions. And then I'll go back to my main window Visual Basic file, mainwindow.xaml.vb, and I'll add code that creates an instance of that class and then calls the methods from that instance. Right here, before the select case statement, I'll add a bit of space, and I'll create a new variable called calc, and I'll set its data type as an instance of my Calc utility class. Then I'll instantiate it with this syntax, new Calc utility. I'm calling something called a constructor method. In Visual Basic, if you create a class and you don't define a constructor method, the compiler adds a constructor method for you. It's called a no-arguments constructor method, and it simply returns an instance of the class. So this is the call to the constructor method, and it returns the instance of the class, and calc is the variable that's pointing to that instance. We call this a reference variable. It's referring to the object in memory. Now, I'll change the way that I'm calling these methods. Instead of using the name of the class, I'll use the instance variable, calc, and I'll make that change to all 4 method calls. After making those changes, all of the error indicators go away, and I'll run the application and do a quick test. And all of my operations still work. Now I'm ready to add instance fields to the class. I'll go back to calcutility.vb and open up to full screen. You declare instance fields as members of the class by declaring them inside the class declaration but outside of any functions or subroutines. I'll place this new code here. I'm going to declare 2 instance fields. I'll start with the keyword public, then the name of the field, and I'll call it value1 and set its data type to double. Then I'll do the same thing and create a second instance field called value2, also data typed as double. Next, I'll go through each of the functions and change them so that instead of receiving arguments, they'll operate on the 2 instance fields. So I'll remove the arguments from add values, subtract values, and so on. Then, in the return statements for each function, I'll change DBL to value. And I'll do that with a little bit of searching and replacing. I'll go to Edit, Find and Replace, Quick Replace. I'll type in DBL and replace with value. And then I'll click Replace All, and the changes have been made. Those are all the changes to the class. Each of the operations now operates on the 2 instance fields, value1 and value2. So it's up to the calling scope of the application to set these values and then call a method. I'll save those changes and go back to my calling scope. After I've created the instance of the class named calc, I'll assign values to its instance fields with this code. calc.value1 equals dbl1 and calc.value2 equals dbl2. I only have to do this once before I get into the select case statement. And now that those values are set, I don't have to pass them into the functions, which no longer accept them anyway. So I'll remove them from the calls to the 4 functions. When I save my changes, all of the error indicators have gone away. So now the architecture of my application is a little bit different. Instead of passing in these values to each of the 4 functions, I'm setting them as values that are a part of the object, the calculator utility object, and then calling the appropriate method. I'll run the application and test it with a couple of values. and see that all of the operations still work. So I've now shown 3 ways of organizing your code, starting with modules, where you simply are sharing functions with the rest of the application, then going to classes that have their own shared functions, and now showing a class that's designed to be instantiated and can store data and operate on that data. It's your choice as developer of which architecture you choose for your application. As you get deeper into the use of object-oriented techniques in your own programming, you might decide, as I have, that this approach makes your code easier to maintain for the long run.